Hello, my dear students. Let us discuss about earth pressure. Before starting earth pressure, you all should know what is retaining structures. Structures which are used to hold back the soil mass are called retaining structures. So first, let us see what are the functions of the wall. Suppose in a hilly areas, you want to develop some facilities like a road. Then what you have to do? You have to cut the hill and make a road. Now, if the hill slope is too steep and hill rock quality is not good, in that case, you cannot keep the cut surface of the earth just open. Sometimes you need to support. Similarly, while making a railways in some places, you have to cut the soil, excavate the soil, and some places you have to fill. When you are cutting the soil, then the soil has to be retained by the retaining wall. Similarly, when embedment is made, that also has to be retained by the wall. So, while designing retaining wall, actually you have to find out how much pressure is coming because of that backfill. So, this is the intention why you need to study the earth pressure theories. Okay, so there are different types of retaining structures. Let us see some of the examples. Gravity walls and semi-gravity walls, cantilever walls, and Gabion retaining walls and sheet pile walls. This is the gravity walls. Here you can see this is the backfill, and this is semi-gravity walls backfill, and this is the cantilever wall, and here this is fixed, and here it is allowed to rotate. Because here one side is fixed, it is called as cantilever walls, and this is the backfill. And here you can see this is the Gabion retaining wall, and here this is actually or a typically Gabion wall, and here using wire mesh you can make a big box, and inside the box you have to keep a big size rock masses like gravel or boulders, and then these boxes are connected. So like this you can see these boxes, and these boxes are then connected. So if you put another opening, they will also have to be connected here. So when they are used like this and one after the other and stressed again and again, the entire soil or entire mass become like a wall, and behind that wall soil can be retained. Okay, so that is about the Gabion retained wall. It is made by, there will be a wire mesh, and this wire mesh is filled with the bigger sizes of soils, that is gravel and boulders. Then they are interconnected each other. So it looks like a box. And this is sheet pile wall. Here you can see here, this is sheet pile wall, and here there are thin sheets, and they are interconnected each other. So this is one piece here, this side is one piece, and this is the another piece. So this will be penetrated, and this will be penetrated, and this will be locked, and then penetrated, and then again it is locked. Like that, this process will be continued. So one after the other are connected and penetrated. So it is in the form of a wall, and this retains the soil. Okay, this is about sheet pile wall, and now we'll see what are the different uses of retaining walls. It is used for embankment. These are the retaining walls. So it is used for embankment, and it is used for cutting, and also it is used for the bridge abutment, and also to store the water, and flood walls sometimes to in order to resist the flood, it may have to be it has to be retaining walls have to be constructed. Then sheet pile walls. These are the some of the uses of retaining wall. So mainly this retaining walls helps in maintaining the ground surface at different elevations on either side of it. It is always necessary to compute the pressure exerted by the material behind the structure. If the pressure exerted is of due to earth filling, then it is known as earth pressure. As the pressure exerted by the earth backfill always acts laterally on the structure, it is called as lateral earth pressure. The material retained or supported by the structure is called backfill, which may have its top surface horizontal or inclined. Okay, this is about the earth pressure. Mainly, the pressure that is exerted by the earth, it is always lateral, so it is called as lateral earth pressure. And then we see what is the plastic equilibrium in soil. When the body is said to be in plastic equilibrium, if every point of it is on the verge of failure. Okay, this theory was first developed by Rankine. He investigated the stress conditions corresponding to the states of plastic equilibrium. Okay, then it is developed by other scientists. So now let us see the stress condition during plastic equilibrium, which can be represented by the following Moore-Coulomb equation. So this is the stress condition which is developed by Moore-Coulomb. Sigma 1 minus sigma 3 divided by 2 minus sigma 1 plus sigma 3 divided by 2 into sin phi, that is equal to C into cos phi. Okay, here sigma 1 is given by this formula, 2C tan 45 plus phi by 2 plus sigma 3 tan square 45 plus phi by 2, where sigma 1 is equal to this equation and n phi is equal to this equation. Okay, now here what is this sigma 1? Sigma 1 is a major principal stress and sigma 3 is the minor principal stress in the soil mass at failure. Now, there are three types of earth pressure on the basis of the moment of the wall. So, the first one is earth pressure at rest, second one is active earth pressure, and third one is passive earth pressure. Okay, you can see here this is the active case. Here wall moves away from the soil, and here there is no movement, so that is at rest case. And here walls moves towards the soil or walls moves into the soil. So this is passive case. Okay, now let us see how you can explain this pressure at rest. When the wall is at rest and the material is in its natural state, then the pressure applied by material is known as earth pressure at rest. Okay, it is represented by P naught. Next, active earth pressure. When the wall moves away from the backfill, there is a decrease in the pressure on the wall, and this decrease continues until a minimum value has reached, after which there is no reduction in the pressure and the value will become constant. This kind of pressure is known as active earth pressure, and it is represented by PE. Next, a passive earth pressure. When the wall moves towards the backfill, there is an increase in the pressure on the wall, and this increase continues until a maximum value has reached, after which there is no increase in the pressure and the value will become constant. This kind of pressure is known as passive earth pressure. It is represented by PP. Okay, so pressure at rest is P naught and active earth pressure is PA and passive earth pressure is PP. Okay, now we'll see how the pressure developed in active case and passive case. If the let us take first active state. Okay, if the retaining wall is permitted to move away from the backfill, allowing lateral expansion of the soil. As a result, what happened? Earth pressure decreases with increase in the expansion. Here during the active state, the wall moves away from the backfill and a certain portion of the backfill located immediately behind the wall breaks away from the rest of the soil mass. So this forms a wedge shaped portion. This is a wedge shaped portion. So this is how it forms because of the wall moves away from the backfill. Certain portion of the backfill located immediately behind the wall. That moves away from the rest of the soil mass. So this forms a wedge-shaped portion of the backfill tending to move with the wall. So this is called as the failure wedge. This is called as the failure wedge. Okay, so here further expansion will cause shear failure of the soil, in which the sliding of the failure wedge tends to move in forward and downward direction. You can see here. Okay, so shear failure of the soil happens, which moves in the forward and the downward direction. So the resisting force, which is developed due to shear strength of the soil in the upward direction. You can see here, this is the resisting force which is developed due to the shear strength of the soil in the upward direction along the failure plane. This is the failure plane, along the failure plane. This failure plane is also known as slip line. Okay, this failure plane is also known as slip line, which makes an angle of 45 plus pi by 2 with respect to horizontal. So which makes an angle of 45 plus pi by 2 with the horizontal. At this stage of failure, the earth pressure having minimum value. So this minimum pressure is known as active earth pressure. If the wall is smooth, the earth pressure acts normal to the back of the wall. On other hand, if the wall is rough, the earth pressure acts at an angle delta normal to the wall. Okay, so this is about here. Normal. If the wall is rough, which makes an angle of delta normal to the wall. So this is the vertical force, and here this is the active pressure developed, and this is the angle 45 plus pi by 2. So this is about active case. Then let us and here you can see this is the stress condition, and this is vertical force and this is the horizontal force. In the case of active state, the vertical force is sigma 1 and horizontal force is sigma 3. Okay, that is opposite in the case of passive state. You can see here in stress condition, this is vertical force, this is horizontal force, but vertical force equal to sigma 3 and horizontal force equal to sigma 1. Okay, so in the passive case, what happens? The wall is permitted to move towards the backfill, causing lateral contraction of the soil. When the wall moves into the soil or towards the backfill, there will be a contraction of the soil. So larger force is required to move a greater distance until the stage of failure is reached. At this stage of failure, the sliding wedge is formed. This sliding wedge is formed, and this wedge of soil mass moves backward and in the upward direction. So it moves in the backward and upward direction. So the resisting force due to shear strength of the soil is developed in the downward direction along the failure plane, and this is known as the slip line. This is known as the slip line, which makes an angle of 45 minus pi by 2 with the horizontal. Here at this stage of failure, the earth pressure is at a maximum value. This maximum earth pressure is known as passive earth pressure. If the wall is smooth, the resultant passive pressure acts normal to the surface of the wall. If the wall is rough, the resultant passive earth pressure makes an angle of delta with the normal. So you can see here, this is the passive earth pressure, and which makes an angle of 45 minus pi by 2. I hope all of you understood. Thank you.